before I continue with the example, I guess, of course, people study exponential family also because it's really kind of powerful in Bayesian inference that like every exponential family basically have a conjugate pair, and what conjugate pair mean in Bayesian inference is that like if we have some kind of observation x that is parameterized by some parameter, let's say eta, and let's say we have another for the eta itself is like a random variable and is parameterized by another distribution that with a hyperpair, like let's say lambda here, then the posterior will be proportional. Let's say if you have like n observation, like so here actually I have written down that like n observation x1 up to xn, and so then the posterior distribution given the observation and also the hyperpair lambda, and I want to find back the parameter like eta here. So that posterior will be just proportional to the pair distribution multiplied by the likelihood, or the product of the likelihood. And if the pair is basically has the same form as this likelihood, or like if the pair is the same form of this posterior, that's after the multiplication have the same form, then we say that this pair is the conjugate pair. Then in that case, doing Bayesian inference is very simple, because whenever we multiply the likelihood, we essentially still in the same family of distribution. It's not even family, or the same type of distribution. Then we just say update the parameter lambda to make the to basically have the new update inference.